After winning the World Cup on 29 June, our Virat Bhaiya was very happy and he decided to celebrate the win with some paneer kurchan and garlic naan, his favorite dishes.
पनीर खुरचन खाऊंगा, गार्लिक नान खाऊंगा.
So now he went to the Tomato app and he ordered one paneer kurchan and 3 garlic naan. Okay. Now he's complaining that his order page is taking a lot of time to load his order history. So let's figure out what could be the issue. Hello there, welcome back to our channel. So today we are going to discuss about denormalization in database. So you might be thinking we knew about normalization, but what exactly is denormalization? First let's start about what you already know, right? About normalization. So normalization is nothing but it's about organizing the data into smaller related tables, right? To avoid redundancy basically. Okay. For example, let's say we have a food ordering app and there we are trying to design the database, right? So in our food ordering app, we can have multiple tables like customer table, orders table, order details table, and items, right? The item and price of the menu basically. It's kind of the menu, right? So these are the tables that we have. So when a customer places an order, the data gets split into multiple tables. So if we need to show some summary like this, we'll have to query multiple tables. You have to basically join multiple tables and use multiple join queries. I mean, sure, it saves space and avoids data duplication, but all these joins can slow down your query basically, right? It can drastically slow down your query. And especially, I mean, as the data grows, the number of customers, the number of order grows, right? The query execution will become slower. So we are normalizing the databases to keep things cleaner, first thing. But what is denormalization actually? What about denormalization? Why do we use denormalization? So denormalization is used when we intentionally combine some of the data, right? Some of the data back together to keep things, I mean, redundant obviously, but make the read queries run faster. So instead of breaking the data into many tables, we duplicate some of the data and merge it into a single table. Okay, for example, if I decide to take this customer name column, right? We have this customer name column into this orders table, then it will be known as denormalization. For example, I take this customer name column to here, then it will become denormalization. Basically, I'm increasing the redundancy to make the read queries faster. Okay, so now this means there will be fewer joins and the query execution will be faster obviously. Now let's understand this scenario with an example. Okay, now let's say after winning the World Cup on 29 June, our Virat Bhaiya was very happy and he decided to celebrate the win with some paneer kurchan and garlic naan, his favorite dishes. So now he went to the Tomato app and he ordered one paneer kurchan and 3 garlic naan. Okay. Now he's complaining that his order page is taking a lot of time to load his order history. So let's figure out what could be the issue. Now once the order was placed by Virat Kohli, the customer information, the item details, the order summary, etc. are different tables right now. For example, let's say we have 4 tables like this. Okay, this is the customer table, this is the orders table, this is the order details table, and this is the items table. So let's say in customer table we have Virat Kohli whose ID is 18, customer name is Virat Kohli, and phone number is something, right? And let's say in the items, now let's talk about the items table. In the items table, we have let's say 2 items basically, and ID of the first item is 1, and name is let's item name is Paneer Kurchan, and price per unit is INR 180 rupees. Now let's say we have another item whose ID is 2, and the item name is Garlic Naan, and price is 90 rupees. Now let's say after Virat Kohli placed an order, now we have an order entry in this orders table. Okay, and let's say the ID was 18 and the customer ID was let's say the ID was 8. The customer ID is 18 because Virat Kohli ordered, so his customer ID actual ID was 18. Hence this customer ID is 18 here again, and he placed this order on 29 June, 29 June, and the total order value is let's say 450 rupees. How did it become 450? We'll calculate that now. Now let's say there is another table called order details, which will capture the individual item information which was included in the order, because he ordered 2 items, right, in the single order. So this order details will have information about those 2 items which was placed in the single order. Now let's say we have 2 entries in this order details. So the ID is some random number here, let's say. Now the order ID is 8. This is the order ID, right? This order ID is the 8, and item ID. So in the order ID, the first item was item ID 1, which is nothing but the paneer khurchan, right? So paneer khurchan ID, and how many paneer khurchan did he order? He ordered one quantity of the paneer khurchan. So 180 rupees here. Now in the second item in the order details, now the second item in the order was, let's say, some random number. ID is random number. Order ID is again 8. This is the order ID. This is our order ID, and the item ID. Item ID is 2, which is nothing but garlic naan. And what is the quantity he ordered? He ordered three quantity of it, right? So 90 rupees is, so 90 into 3, 270 plus 180. So total order value is 450. Now, if we want to show a summary of the latest order to Virat Kohli, you want to show a summary like this, like Virat Kohli, name of the customer, the date, the total amount, and what were the items in placed in that order. Now, in order to get this information, see how many tables we have to carry. Okay. Now, if you see this order date and the total item, total amount, we can get it from the orders table. We got the date from here. This date belongs to here. This amount is this one, right? So we got this two information from the orders table. Okay. Now we have the customer ID also, but here we want to show the name of the customer. So in order to get the name of this customer, using this ID, we have to go to the customer table right now, right? So this is the customer ID. Name is Virat Kohli. Now we got the name and got the name of the customer using this customer table. So there was a relation between this to this. Using this customer ID, got the customer name here. So this is one join that we are performing here. Now, in order to get this information, like how many paneer kurchan he ordered and how many garlic naan he ordered, basically what were the items in that order. So what we have to do, we have to go to the order details table. Now in the order details table, we have the order ID, right? We already have the order ID. The order ID was 8. Now using that order ID, we got to know that the item ID 1 and item ID 2 were ordered in this order. This item ID is linked to this ID right now, right? Item ID 1 is paneer kurchan and item ID 2 is garlic naan. So now using this ID, these IDs are not enough, right? Because we need to show the name of the item also. So using this ID, we'll go to the items table. Using this item ID, we'll go to the items table. Then we'll get the item name. Then we'll show here that name of the item. And the quantity we'll get it from here. That, yeah, 1 paneer kurchan and 3 garlic naan. Okay. So this is how, and there is another join obviously between this ID and this order ID, right? These are the 4 multiple joins that we need to perform in order to show a simple summary like this. But in a denormalized database, the information is stored together basically, and the page can be loaded quickly. Basically, this summary we can load faster than this flow. Now, how do we incorporate denormalization here? And let's understand that. Now, let me remove all these arrows. Now let's say I decided to bring 2 information into one of the table. Let's say I want to bring the customer name information in this table to this table. Okay, and this item name column is column that is there, right? This item name column, let's say I want to bring it here. Okay. Now let's analyze with this structure how many joins we have to perform in order to get this same summary. So what we did here basically, now in the orders table we brought in the customer name. So basically in the orders table, along with the customer ID, we brought in the customer name, and in the order details table along with the item ID, we brought in this item name, and here also it is garlic naan. Now in order to get this summary, first what we'll do, we'll go to the orders table, right? Yeah, we went to the orders table, and Virat Kohli's user ID was 18. So using 18, we found that yeah, latest order was done on 29 June. The amount is 450 and name is Virat Kohli. So from this single table, now we are able to get all these three information. We'll use these three information to show the starting three information from the single table. So basically, we are now free of this join. You don't need this join anymore, right? So this join is not required. Now, in order to get this information about how many paneer khurchan, how many garlic naans were ordered in that particular order, so what we can do, we'll use this order ID. Using this order ID, we'll come to know that yeah, against this order ID, two items were ordered. So one paneer khurchan and three garlic naan. So this way we got rid of this mapping also, right? So item ID to this ID that was there, we got rid of this mapping also. So the only mapping that we needed is the order ID to this, right? This order ID to this mapping we needed, because using this number 8, we filtered out some records from this order details table. So right now we saw that using only single join, we are able to prepare the same summary. Earlier we required 3 joins. Using normalization and using denormalization, we require only 1 join. Now the query with this denormalized structure will run way faster than the normalized one. Okay, faster it sounds great, but does it not sound like we are duplicating data? Like, isn't that a bad practice? So yeah, true. That's a trade-off basically. So denormalization sacrifices some storage efficiency, right? We are introducing redundancy here. We are storing customer name here also and customer name here also. We're storing item name here also and item name in the items table also. So denormalization sacrifices some storage efficiency and consistency for speed. Okay. So we'll need to be very careful with updates basically. Let's say Virat Kohli changed his name, which is very very rare. Or let's say the restaurant wanted to update the name of this dish from paneer khurchan to some paneer, I don't know, some durchan maybe. Okay. So in that case, the updates will be costly because you have to update the name here also and update the names here also, the item name in the order details table also. So updates are costly, but a person changing his name or changing the name of a item in the menu is not done quite often, right? So now the question comes is, when should I actually use denormalization? So denormalization is ideal for read-heavy systems, right? Like our food ordering app, where customers frequently query data about their orders and they hardly update their information, like the name, or restaurants hardly update the name of the dishes, right? In those cases where updates is not that much frequent, right? Or in those tables basically where the update is not that much frequent, but read is done quite frequently. In that case, we can consider denormalization. So it is quite common in data warehouse and distributed systems, where minimizing the number of joins improves the query performance a lot. So now you got it. So by denormalizing, we reduce the time spent to join multiple tables together and made the page load faster. So just remember that there is a board called denormalization for your rescue when you are in the flood of database optimization challenges, right? You can think about denormalization definitely. So now let's discuss a little bit about the pros and cons of denormalization. Let me go to here. So obviously, as we discussed, the pros of denormalization are faster query processing. Obviously, because the number of joins are less, the query becomes simpler because the lesser the number of joins, the simpler the query becomes. And this is again less joins. That means obviously less disk I will be done because lesser number of tables bring into the memory and then join them to run the query, right? So, and as we discussed, it is optimized for read heavy workloads, as we discussed, where updates are not that much frequent, where updates are very minimal, as we discussed about the customer name or menu table or items table, where the updates are very not much frequent, right? Uh, So there we can consider this, but it has some cons also. What are the cons? Obviously, we are introducing data redundancy and risk of data inconsistency. So somehow, let's say Virat Kohli updated his name, but we forgot to update it in the orders table, then there will be inconsistent between the name in the customer table and in the order table. Okay, so risk of data inconsistency is there, but we have to be aware about that, and we have to plan on how to manage it. And obviously, as we discussed, the updates and the writes will be slower, because if the restaurant updates the name of the dish from paneer khurchan to paneer bhujia, something like that, we have to update it in two tables instead of only one. So these are the cons. Now let's summarize when to use denormalization basically. So when reads are more frequent than writes, we can consider using denormalization. Then few points are joining causing performance bottlenecks. Right? If the multiple joins are causing a slowness in your system in loading pages or loading parts of the web page, right, or parts of the application, then you can consider using denormalization. Data doesn't change too often, and data warehousing, as we discussed, obviously, because in analytical workflows, the cost of data redundancy is far outweighed by the benefits of faster query performance. Because in data warehousing, a larger amount of data is processed, right? So there processing the data faster becomes more important than the storage consideration or storage concerns. So in those cases, we can use denormalization. So try denormalization if you are struggling with slow database performance and slower execution of query despite having implemented normalization in place. It will definitely give your system a performance boost it needs. And if you found something interesting and got something new to learn today, so don't forget to hit that like button and share it with your friends. And as usual, a small request: subscribe to this channel so that I'll keep making this kind of fun and entertaining learning videos for you. And stay tuned with this channel to become a better software engineer than yesterday. Thank you.